Hello children, as you know we are discussing the chapter a pair of linear equations in two variables, and we know the linear equations will be of the degree 1 which are equated to some constant or variables, thus it becomes an equation in two variables. And the general form of these will be a1x plus b1y plus c1 is equal to 0. So the second equation's general form will be a2x plus b2y plus c2 is equal to 0. As I had explained to you in the class that first of all we should be very good to understand the question, and we should know to convert the verbal problem into the algebraic form. Then from the algebraic form we can convert it into the graphical form. Let us take an example. The first example which is given in the textbook of Akila. So let me read out the question for you. Akila went to a fair in her village. She wanted to enjoy rides on a giant wheel and play hopla. Hopla is a game in which you throw a ring on the item kept in a stall, and if the ring covers an object completely, you get that. So this was the situation given, and let us see what is the next situation. The number of times she played hopla is half the number of rides she had on the giant wheel. If each ride costs rupees 3 and a game of hopla cost rupees 4, how would you find out the number of rides she had and how many times she played hopla, provided she spent rupees 20 on it? So as when we start converting, let us start like, let the number of times she played hopla be y, giant will be x. And as you can see, number of times she played hopla is half the number of times she played giant wheel. Therefore, we get the equation as y is equal to half of x. So when we take the RHS to the LHS, we get the equation as x minus 2y is equal to 0. Let us consider this to be equation 1. And as she pays rupees 3 for each ride of giant wheel, that will be 3 into x plus 4 into number of times she played hopla will be y. So rupees 4 she played to play hopla. So together she spent rupees 20. So when we solve this graphically in the graph book, we get the following graph. And as you can see, these are the two lines which represent each equation. And how are these two lines? The lines are intersecting to each other. Remember this, with the help of an equation, we will be knowing how will be the lines just by knowing some relationship. So let us take the second example. We take the second example of Romila. So as Romila went to a stationery shop, she purchased 2 pencils and 3 erasers for rupees 9. Her friend Sonali saw the new variety of pencil and eraser with Romila, and she also bought 4 pencils and 6 erasers of the same kind for rupees 18. So they have asked us to represent this situation algebraically as well as graphically. So how do we? So when we look at the graph, it looks like this. It's not a single line. Actually, both the equations, if you represent them graphically, they will overlap on each other. Means, in the sense we can tell that the lines are coinciding with each other. So let us take one more example. So this is an example of rail lines. So as you know, the rail lines are represented with the equation x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. So when we draw the graph for this, you can see the graph is as follows. And how are the lines to each other? So we can say that the lines are parallel to each other. So let us understand, just by looking at the coefficients, can we tell the nature of lines? So that is what the relationship between the coefficients and the nature of lines. So I have written all the 3 set of pair of equations here. So as you can see, we have formed a table. So these are the equations, and here a1 is the coefficient of x in the first equation, a2 is the coefficient of x in the second equation. So when we divide a1 and a2, so a1 by a2 will give us 1 by 3. So as you know, a1 is the coefficient of x, that is 1. So coefficient of x in the second equation 3, 1 by 3. b1 by b2. So b1 is the coefficient of y in the first equation, that is minus 2. b2 is the coefficient of y in the second equation, that is plus 4. c1 by c2. These are the constant terms of first and second equations. c1 is equal to 0, c2 is equal to minus 20. So on comparing, we can tell that a1 by a2 is not equal to b1 by b2. And how are the lines? The lines are actually intersecting. So when they intersect each other, how many solutions can we get? So we get exactly one solution or only one solution. Let us try the same with the next example. So here a1 by a2 can be written as 2 by 4, isn't it? b1 by b2 can be written as 3 by 6. c1 by c2 can be written as minus 9 by minus 18. So when we observe, when we cancel these two, we can see that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So this is actually the question of Romila. So how was the graph in the Romila? So here is the graph of Romila. How were the lines to each other? The lines were coinciding. Therefore we can say that if these ratios are equal to each other, so graphically the lines are coinciding. When they coincide on each other, so how many solutions do we get? So every point overlaps on each other. Every point. So how many points can we say? We can say that infinitely many solutions. So let us take the example of the rail lines, as we have the same here in the same page. So when I write a1 by a2, a1 is 1 divided by 2, b1 by b2, 2 divided by 4, c1 by c2 gives minus 4 divided by minus 12. When we see 2 ones are 2 twos are. a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. That is the relation. a1 by a2 is equal to b1 by b2, but not equal to c1 by c2. How are the lines? The lines are parallel. So when we have parallel lines, if the lines do not meet with each other, then we can say that there are no solutions.